Hello class, this is Mr. Lehman. Today we're going to continue looking at types of chemical reactions, and we're going to look at the third type today. We commonly call this a single replacement reaction. Other names for it are single exchange reaction or single displacement reaction. So in this, the general setup, we have an element, something by itself, typically a metal in the solid form, and we place that in an aqueous solution. An aqueous solution, an ionic compound is dissolved in water. The metal, if it's more reactive than the metal that's part of the ionic compound, the metal that's by itself will replace the metal that's part of the compound. So more reactive metal wants to lose its 1 or 2 or 3 valence electrons to get a full outer shell, and so it's able to kick out the less reactive metal and to bond with the nonmetal, the anion. That will result in a different element. If it's a metal replacing another metal, then we'll have a different metal by itself, the less reactive metal by itself, and then the more reactive metal will combine with the anion, the negative ion, and we'll get a different solution. So we call single replacement reactions, going back to the dancing, we call this the cheater, right? So the couple splits up, neither the guy switches dance partners, dances with a different girl, or the girl switches dance partners and dances with a different guy. Alright, so the reaction is going to start out with 2 substances. One has to be an element, one has to be an aqueous ionic compound, a dissolved ionic compound in water. The only way that this reaction can occur is if water's there to facilitate the reaction so that the ions are free from one another and are able to switch places. And then we have to consult the activity series to see whether or not the element that's by itself is more reactive than the element of the same species that's in the compound. So here's the list, the activity series. So here's hydrogen. Hydrogen is a nonmetal, but we still put it on here because oxygen has a positive oxidation number. Hydrogen loses one electron to become stable, just like metals lose electrons. So lithium is the most reactive, gold, platinum, silver are the least reactive. Not surprisingly, that's why we make jewelry out of them and valuable things like statues, because they resist reacting. Alright, so let's look at how this works. So here we have aluminum metal by itself, and so we look at the ionic compound, it's dissolved, it's aqueous, so we look and say, alright, here's the metal, so I got to compare metal, aluminum versus lead metal, and I look at that activity series. Aluminum is here, and lead is down here. So aluminum is higher on the list, and so the most reactive metal is up top, the least reactive metal is at the bottom. And so if my free element is higher on the list than the element that's in the compound, then the reaction will proceed. And so because aluminum is more reactive, it'll kick out the lead. The lead will be by itself. And so we're going to form aluminum nitrate. So aluminum nitrate, aluminum is +3. Nitrate is -1. That's why we have to learn the ionic charges of the polyatomic ions. Alright, so this is still going to be dissolved in water, and then the lead will be by itself in its pure elemental form, which is a solid. If we look at the next one, hydrogen and lithium. Lithium is more reactive than hydrogen, so lithium can kick out the hydrogen, and so lithium will link up with the chlorine to form lithium chloride, and that will be dissolved in water. +1, -1, so that's happy and stable. Chlorine is diatomic, it's a gas. And I'm sorry, I did not want to do that. I want hydrogen, not chlorine. Hydrogen gas is going to form. It's diatomic. And so we'll get some bubbles of hydrogen gas forming, which is explosive, right? If you like that, it's going to be explosive if it's in a sealed container. Hydrogen gas versus copper oxide. Now here, hydrogen, copper, we looked at our list. Here's hydrogen, here's copper. So hydrogen is just slightly more reactive than copper. And then hydrogen versus magnesium. Alright, There we go. If we had another one, let's say we put one more on here. Let's say we have copper metal plus, we'll go magnesium oxide. Would anything happen here? So if I go back, I look at my activity series. Here's magnesium. Here's copper. Magnesium is more reactive than copper. And so if we look at this, copper cannot kick out the magnesium. So you would just write no reaction. Nothing would happen here. They would sit there and nothing would happen. Alright, so I hope this helps. We'll come back and we'll take a look at some more. Double displacement reactions next, double replacement.